Hi guys, and welcome to another video. Today's video lesson, we're going to be looking at proving trigonometric identities. If you look at the series of videos so far, we are up to this point here, which is proving trigonometric identities, and all previous sections have been covered in previous videos. So let's get on with it. And before I start this video, I want to dedicate this video to a very special person, Mr. Gokul, who recently passed away. He's been an inspiration to all in the field of e-learning, and he's a pioneer in e-learning, and he will be forever remembered. May his soul rest in peace. So let's continue. It says grade 11 maths trigonometry, proving trigonometric identities, and this question is from the November 2019 paper 2. And let's get straight to it. It says here in question 5.3, prove the identity. Prove 1 over tan squared x minus cos squared x equals to cos x to the power 4 all over sine squared x. Now when you are asked to prove, remember that you have two sides to an equation, a left-hand side and a right-hand side. In general, the left-hand side is more complex than the right-hand side. So what we do is we generally write down left-hand side and we try as far as possible to prove it equal to the right-hand side. There are special cases where we'll have to reduce or simplify both sides. Things that we ought to know in this particular section: theory, and it's as follows. We need to know that tan of x, and whenever we see tan of x, we will write down sine of x over cos of x. The next thing that we need to know is that sine squared of x plus cos squared of x is equal to 1. Therefore, sine squared x is equal to 1 minus cos squared x, and cos squared x is equal to 1 minus sine squared x. And there we go. That's basically all we need to know as far as theory is concerned. The other very important thing that we ought to know is the concept of lowest common denominator. For example, if I have 1 over x plus 1 over y, and I ask you, let's simplify this particular fraction. We need an LCD. In this case, the LCD will be x, y, and to simplify our numerator, remember, x times y is xy. Therefore, we're going to get now, what don't we have? 1 times y would be y. And here we'll say plus. Remember, we got y times what is xy? Y times x, so 1 times x is x. So therefore we have y plus x over xy. So the concept of lowest common denominator is very important in this particular section. Let's answer our question. 5.3. So we'll write down the left-hand side, which is this whole side here. So we'll say left-hand side is equal to 1 over tan squared x minus cos squared x. Here now, remember, cos squared x can be written as cos squared x over 1, so we can write that down. So what's the LCD here? Tan squared x. So the LCD there will be tan squared x. Remember, you got tan squared x there and you got 1, so the LCD, lowest common denominator, is tan squared x. And what you're left with now? You're going to be left with 1 minus cos squared x times tan squared x. So continuing, now remember, tan squared x, as the theory suggests, tan of x is equal to sine x over cos x. So we're going to write down 1 minus, and we're going to say cos squared x times sine squared x all over cos squared x. That's all over. Here we got tan squared x, so let's change that 1 time to sine squared x all over cos squared x. And that's what our theory suggests. So what you'll be left with here, so we can simplify. Cos squared x cancels with cos squared x, and we are now left with 1 minus sine squared x. 1 minus sine squared x, there's it here, is equal to cos squared x. So our theory is very, very important. Therefore, you're going to write down here cos squared x. Now remember, you're dividing by a fraction. So therefore, we're going to change this division to multiplication and invert this bottom fraction here. So it's going to be cos squared x all over sine squared x, which leaves us with cos squared x times cos squared x is cos 4, cos to the power 4 there, cos x to the power 4 all over sine squared x. And if you go and look at our question, cos x to the power 4 all over sine squared x is what the right hand side is. So therefore, that now equals to the right hand side, and that's now proven. Let's go look at another question. So the question that we just looked at was from the November 2019 paper 2. Now let's look at another question from the November 2018 paper 2. Let's see what they tested here. So they asked you in this particular question, 5.3 once again. They said prove the identity 1 over cos of theta minus cos of theta all over 1 plus sine theta equals to tan theta. So remember, now that's my left hand side, that's my right hand side. So let's prove the left hand side equals to the right hand side. So write down the number 5.3. We'll write down left hand side equals to 1 over cos of theta minus cos of theta all over 1 plus sine theta. 1 plus sine of theta equals to, once again, what's my LCD going to be? My LCD will be cos of theta into 1 plus sine of theta. Let's simplify our numerator. So we've got 1 times 1 plus sine theta. So therefore we'll be left with 1 plus sine of theta. Brackets if we want to. And here we've got 1 plus sine theta. Here is my denominator. So therefore, to simplify my numerator will be minus there, and cos theta times that cos theta there will be cos squared theta. Right. So now let's simplify. So what are we going to be left with here? So therefore now, we must now try to expand in such a way that we can simplify this particular expression. So let's see now what am I going to do here? Remember that my right hand side here is tan of theta. So what is tan of theta? Tan of theta is sine of theta over cos of theta. So my aim is to get sine of theta over cos of theta. So therefore, what I'm going to do is now I'm going to expand this minus cos squared theta as follows. So I'm going to write down 1 plus sine of theta. I'm going to say minus into, what is cos squared theta? 1 minus sine squared theta. And in the bottom here, we're going to be left with cos of theta into 1 plus sine of theta. So let's see what we're left with now. So we're going to say 1 plus sine theta minus 1. Minus times minus, there will be plus sine squared theta all over cos of theta into 1 plus sine of theta. So what happens now? The 1 and the minus 1 both cancel. And now you are left with sine of theta minus, we're left with plus sine squared theta. So here we can remove sine of theta as a common factor. So it's going to be sine of theta into 1 plus sine of theta. There you go. And there you got your cos theta there. And you got 1 plus sine theta. Right, so we removed sine of theta as a common factor there. And what do you notice? We got 1 plus sine theta in the numerator, 1 plus sine theta in the denominator. So what happens? It cancels, right? So now you're left with sine theta over cos theta, which is equal to tan of theta, which is equal to our right hand side. Therefore, we have now proven this particular identity. Learners, Once again, grade 11 Maths Trigonometry, Proving Trigonometric Identities. If you haven't subscribed already to JL Maths on my YouTube channel, please do subscribe. You can like my Facebook page as well, Justin Lazarus Mathematics, and you can watch all videos in order of the work schedule on jlmaths.com. And I'll catch you in the next video.